Hey everyone, welcome to our exciting panel. We have a fantastic set of panelists today, and I hope that everyone is fed and you're ready to dive into something very interesting. We're going to dive into the intersection of two domains that all of you know about, which are AI and space, but whose convergence is far less known. There has been many moments in the recent history of AI when artificial intelligence went out of labs and became something that people were talking about. Think about large-scale expert systems in the past, or the day when Deep Blue won over Kasparov in chess, or the recent wave and hype of generative AI, which is transforming how we live and work so much. Space technologies, in turn, might also be approaching a pivotal moment. There are some indications of that. For example, many things are changing exponentially right now. For example, the number of satellites in orbit has gone up by the factor of 10 over the last years, or the prohibitive cost of getting the payload to space has plummeted, or we have so many startups and commercial companies in space. So it feels like that this area is also going to be very, very different already in a few years. But the question is, how can AI transform space technology and help it become even more usable, bring more value to us on Earth, and unlock new orbits? So this is what we're going to talk about today. We know the names of the panelists, but let us start with a proper round of introductions. Please go one by one and tell us a little bit about who you are and what your company does.
Hi, I'm Dr. Mong Suan, and I'm a co-founder of Kumi Analytics. Kumi Analytics integrate AI and data, satellite data to provide insight of economic and environmental insights.
Hi everyone, my name is Jon. I'm a co-founder of Nika, which is a spatial computing company based out of Singapore. Our flagship product is Nika Planet, which is essentially a Databricks for GeoAI. Some of the type of models our customers build include climate, infrastructure, as well as obviously satellite-based models from imagery to sensory-based models.
Hi guys, my name is Floyd DCosta, and I'm the co-founder of Space Armour. We actually started out in cybersecurity, but then since then we've assembled our own AI engine, which we are now deploying on an NVIDIA Jetson card and launching it into space, exploring in-orbit edge AI use cases. We're taking a platform approach, but for us it's about how can we deliver AI for space in space.
Hi everyone, I'm Rohit, and CEO and co-founder of Transcelestial. We build lasers in space. We are using lasers to provide internet worldwide. We are building a giant undersea cable in space to power internet worldwide, and then also starting next year, data centers in space. So if you're looking at virtual machines to put your AI in space, give us a shout.
Amazing, amazing. What a great panel today. So I suggest we start from making the whole concept of AI in space less theoretical, but much more practical. Let us show to everyone that there are applications that are happening already right now. It would be great if each of you picks just one use case, how you're already using AI, how it helps in your business.
The satellite data is so rich. I mean, we have data all the way in the 80s, and you have the whole world coverage. So one of our products is SketchSat. It is a measurement and validation product to measure carbon stocks in forests before the carbon stock is registered as carbon credits and so as carbon credits. So this product is used even from the beginning of the project, where we work with project developer to choose a project site and choose where the project developer can measure, do ground measurements of the forest trees. So we use satellite for land cover estimation to identify whether a certain area has been deforested and cannot be used for the carbon credits project, and to identify spots where the ground measurements can be accessible for measurements. From that, we the satellite data is very dirty, like meaning is you have atmospheric noise. So we do use AI to clean it up. We use AI to remove the cloud and shadow. And for that, we do the measurements. There's a lot of features, a lot of different data from the satellite data. And we fuse it and do the biomass measurements. So these are quite a lot of AI that is algorithmic AI algorithms that are used for our product.
For us, one clear use case is actually the model our customer built our infrastructure. This is related to some work that they're doing for the Bahamas government, where they're actually trying to utilize satellite imagery to actually predict why certain seagrasses are actually dying in the Bahamas. And the reasons because it's a huge importance to the government, because that's where a lot of their tourism revenue comes from. So these are the type of models that are trying to predict and determine why certain seagrasses might be dying.
Great. For us, like I mentioned, we're taking more of a platform approach. So what we have is our entire AI engine, which will be hosted in space. And I guess, as down on Earth, we continue to rely more and more on space for a whole lot of services. I think that's where we're looking at enabling AI in space. Just to give an example, today, if you even look at Earth observation, a lot of data is collected, GBs of data, and then sent down to Earth and processed on the ground. Our take is that if you can just process that in space, then you don't need to send all that data to the ground. But instead of GBs of data, you just send the 1 MB of the 5 MB file, for example. That's what's really required. The other case is also, stretches beyond. If you look at climate impact or disaster warning systems, again, instead of sending that data down to ground and processing it and trying to trigger alerts, you can process that in space itself and take away all the lag and latency and instantly broadcast threat alerts, thereby being able to more efficiently basically deliver warnings to prevent loss of life or property. Just a few examples, but then it goes even beyond defense and further out there.
Yeah, just very quick, there's 3 ways we use AI. One is on a device level, AI allows us to, different kinds of machine intelligence, but it allows us to beam lasers very accurately at long distances. So for example, last year we beamed lasers from LA all the way to Palm Springs to provide internet for Coachella Music Festival. So if you guys were streaming 4K videos of Coachella, that was thanks to us. Second, national sovereignty is not guaranteed anymore. We have 3 major battles going on, and bulk of that battle is being fought on the intelligence front. And we are not talking about traditional intelligence, but machine intelligence. So one of our use cases is how our non-jammable communications, which we use as lasers, can effectively allow ship swarms and drone swarms to protect your borders, to protect your citizens, but also deter any kind of forces that want to take that sovereignty away. And the final one is space. Transcelestial, as the name suggests, we believe that humanity's future is in the stars. And we are building the telecommunication systems for us to go deeper, to send von Neumann pure probes or similar kind of machine intelligence in deep space. What is extremely critical to make that happen is data centers and connectivity. And so it's kind of like a mix and match of where we use AI and what kind of intelligences we use. Some are dumb AI, some are smart AI, but yeah, it offers a lot of open capabilities to us. Yeah.
Thank you. Great. I feel there are so many use cases, and the whole range from incremental improvement of what you do anyway to unlocking new use cases is there. But applying AI in the business environment is always tricky because there are so many difficulties to overcome. The examples are availability of data, availability of compute and infra where you need it. If you don't have time to send data to the server, you need both compute facilities and energy where you are. Or if you use AI to make autonomous decisions, you need to trust AI. Do you face any of these limitations in your work? And if yes, how do you overcome it?
Yes, definitely. So we use Google Cloud and AWS. They have all the data set in their cloud storage. So we can search the relevant data. Some of the problems we have is the quality of the data that we use to train a model. Like sometimes some data are not available, like when the cloud and shadow is missing data, and also because what we are tracking is, like for example, carbon stocks, the forests in different parts of the world are so diverse, and we have a lack of data for training. So there's quite a lot of problems to solve, and also the computational complexity. The AI algorithm is so rich. There's so many types of combination we can use. So we have to work on optimizing the model and try to reduce the complexity. Like every pixel, there be a certain value. Do we need to store in like things like 8 bits or 4 bits and stuff like that? So there's a lot of optimization to do.
Before we move to Jon, but would it be fair to say, Mong, that for your company, since it is directly in the analytics space, AI is paramount? Without AI, you just would not be able to deliver the quality and value that you deliver.
I don't think so. No.
You don't think so?
Yeah, because AI is so powerful, so it does provide better precision, better quality of insight of such a vast amount of data.
Okay.
Data, yeah.
Thank you, Jon.
Yeah. One of the types of models that we've been building for our customers is flood risk models. For example, in Bangkok, flooding is a huge issue, and satellite is a great use case in space technologies to actually help you to use historical data to understand the risk in certain areas. But one of the inherent limitations of AI is that you're using primarily historical-based data. I think Dr. Suan talked a lot about that, to simulate these kind of scenarios based on historical data. I think kind of the next thing that we're really looking at is how can you do things better predictively, which is still very, very challenging at different times, because some of these simulation-type algorithms are required for urban-based analytics or spatial works is still very, very nascent. So there's a lot of newer work to be done there, and how we can further incorporate satellite-based data to make those models a lot more robust, to help things like insurance companies better predict some of these risks so they can better price their premiums for their customers.
Thanks.
For us, since we are operating space, I think the base challenge that we have is the restrictions. AI requires a lot of energy, and then if you're operating on a small satellite, then of course that amount of energy is not available. Tomorrow we will have new space stations being launched. We'll have in-orbit data centers where perhaps this then gets taken care of. The other challenge is, of course, today we're looking at inference and stuff like that. But tomorrow, if you're looking at autonomous space, autonomous decisions being taken in space, then I think the data, which both of you guys mentioned, plays a critical role. How do you get that data into space so that whether it's robots or whether it's satellites or other objects that need to autonomously make decisions have the latest information and context, not just the large language model at the back end, which they're using to take the decision. So it's not just guardrails and things like that for hallucination, but also the latest data and context, basis which they can then take that decision.
Mm-hmm.
Yeah, it's a tough one because we apply AI in so many places, but I think the big one is you're seeing pretty much all the market capture on the cloud AI side is the traditional like Gemini, Claude, and OpenAI models have gotten so good that for general purpose use cases, the incentive to run things on-prem or on your server has gone away, pretty much. But the other side of the market, which is, I would argue, orders of magnitude bigger, and what we play in, is defense, national security, and some of the more sensitive applications. For that, none of these cloud models ever work because they are optimized for the cloud. So that's where you start looking at two key metrics: cost per serve and latency per serve. So if anyone's out here building solutions on AI and stuff, I would strongly recommend you to not go for general purpose use cases, but work with us and other companies here to understand how can you deliver better cost per serve and latency per serve to private customers like governments and defense, which want to run these models inside their firewall, inside on their prem. And that's one of the challenges we face. So a year ago, I invested in a small startup from Singapore called Featherless AI, and they are now powering the engine behind Hugging Face, where you can plug in like 5,000 different unique open source models. That's the kind of capabilities people need to start thinking about, and what will be majoritarily used, and what we would love to use more and more. Yeah.
Yeah, very clear. By the way, do any of you envision using way more AI already in 1-2 years? So is the usage in your companies going up?
It's definitely going up. So there's enabling technology evolve and it's more efficient and cheaper, and more algorithms targeting to satellite images. Yeah, we definitely see using more AI. So we in like maybe 3-5 years, we see more concentration of using satellite for ESG, for precision agriculture, for urban planning. As things get cheaper and more data is available, for example, algorithms are available in open source, for example.
I'd like to add something which is slightly different. So yesterday I was looking at one of the speakers, Pippa Malmgren from the Geopolitica Institute. She spoke on a number of subjects, but one which caught my attention was what she called textplicity, which is really the amalgamation of emerging tech, where you've got things like AI, you've got emerging financial ecosystem like decentralized finance, you've got the whole blockchain-powered systems, and other emerging tools, IoT and stuff, which together are progressing. I guess when it comes together, you're going to see that real explosion where AI by itself is not going to deliver something, but when it can tie in with some of these other emerging models, some of these other modern approaches, I think that's when you're going to see it going mainstream, because then it becomes so much more easier where AI just becomes something like the cloud, which you use. You really don't bother going underneath and trying to, trying to pick and choose middle underneath. For example, like the folks you said, you've got 5,000 models there. Pick and choose, but that then gets abstracted. Yeah. And once that happens, I guess you're going to see that, go mainstream a lot.
Thanks. A bit of sci-fi in our session. I love it. Jon or Rohit, any ideas on how AI usage can grow in the next years?
Yeah, I mean, a big one is I would like to thank all the VCs in this room for wasting their LP monies and giving us these free AI tools. Congratulations. It's awesome. What that has helped has allowed me to, like, for example, today we write 50% of code using AI, and I spend $0 extra on my budget, which is fantastic. And I think what's happening is from leadership down, I think for a straight period of 4 months, we have some of the coolest engineers in the company, but they are stubborn as fuck. And so you have to stand on their heads and tell them that, dude, your KPI is to figure out how stop laughing and start looking at what parts of you and your team AI can actually truly bring in and solve, right? And unless and until as leaders, you actually show, like for me, I started spending my weekends. We just launched our, I would say like vibe trailer for Transcelestial. Please go and check it out on YouTube. It's a 1-minute trailer entirely built using VO3 clips. And I did it on my own after 3 glasses of whiskey. So, and I think things like that, leaders have to show that they are willing to kind of step up and use AI tools themselves, AI capabilities themselves, like, and I'm talking more about LLMs, but then also for mission critical stuff, right? Like all our pointing and tracking runs on like on-device AI systems, which are a mix of heuristics and large learning models. But effectively now we have capabilities which shoots a laser, where we can shoot a laser from, let's say, Tokyo and hit this cup of coffee in Singapore. And this would not have been possible without machine intelligence. So I think that's what you have to kind of unlock also for your team as a leader. Yeah.
Amazing. Jon, do you want to add anything?
Yeah, I'll just add in very quickly. I mean, as you said, a big issue in AI in space is the lack of data, right? Honestly, satellites haven't been up there for that long. There's not that as many images as we would like. But this is increasing exponentially. I mean, you see, he's sending satellites, Elon Musk is sending hundreds of satellites. So there's going to be a huge data explosion, which is already happening. And that's only, I think, going to make AI more and more prevalent. It's going to make these models a lot better once we overcome some of those issues.
Yeah, I think it would be great to dive a little bit more into that, because I assume the majority of the people in the audience know AI, but know a bit less about space. And it must be very interesting to be able to visualize what actually the infrastructure for AI, for 100x or 1000x of AI that we have today in space needs to be. Because it feels like that there are a lot of limitations. You probably need to have compute there in space. You need to have enough energy. How do you get this energy? So if you could talk a little bit describing this future in simple terms, that would be great. Who wants to start?
I can go first. Because we kind of are having these debates every day right now. So what we will see is, so you know the classic challenge when you put an IoT sensor, how much do you collect at the edge and how much do you process versus how much do you send back and process at the center? This has been a very classic back and forth. So in space, what's happening is all the Earth observation, all the military satellites, they strike a balance between how much data they collect and how much they compute on board. With more high bandwidth laser comms and data centers in space, what's going to happen is you're going to offload all of that to centralized GPU clusters and stuff in space. But there's two major challenges. So very quickly, what you would see, Mark, is us getting to shifting compute and storage capabilities on centralized nodes like we did on Earth. But unlike on Earth, we have two major problems in space. One is sun's energy is extremely weak. And so we have to, we'll get to 5 to 10 kilowatts of data centers, and then we will have a plateau there for a while until we can put small modular nuclear reactors and antimatter reactors up there. So once you get that, then you break the 50 megawatt barrier, and you can start putting more NRS stuff up there. The second problem is heat. Space is cold, but it's infinitely harder to cool things down in space because there is no air. And so what do you do with that, all of that additional heat, which is already a problem for data centers here? So there's a lot of cool innovations coming from on how to handle that. But I think these two are going to be, we're going to quickly get quick benefits, and we'll deploy some AI capabilities, but we'll be restricted on energy and cooling until we can solve those two problems very quickly. There are solutions, but it will take bravery to get there. Yeah.
Great perspective.
I want to add something to what you said. And that's why I'll probably take a different view on the centralized stuff, right? So I was having a chat with, I don't know if he's here, an acquaintance I met. And one of the ideas is he's asking if we can get, his idea is to get a robot on the moon. Now, of course, for whatever the purpose is, you want to use intelligence there. And he's like, can your artificial intelligence then be used for that system? And yes, it does make sense. But that got me thinking, if I'm on a satellite or in orbit on a space station, how do we connect and deliver intelligence with real-time update and context on the moon, for example? Because, again, it's a hostile environment. You want fewer humans and probably more robots doing the job there, right? But then those robots need to autonomously take decisions just like a human would do. So how can you give them the intelligence but also provide the real-time context? And that becomes interesting. Today, like you rightly mentioned, Rohit, everything is centralized. And these are servers sitting in data centers and things like that. But one interesting thing, and I know there are a few guys already talking about, is decentralized AI. And is there a way to distribute the computing so that some of it is computed in space, some of it is or at the edge, and then the rest computed centrally? And then the moment you have that, you can kind of, and again, you can decentralize it and distribute it in space, but also from space to ground. And that opens infinite possibilities.
Amazing.
I'm just going to talk about a little bit more of a maybe practical kind of thing that I see, like just very, people might be able to understand a lot easier. I just think there's not enough talent in our space to actually, I think, deliver that type of 100,000x that we see. And it's very simple. I'll be real honest. The type of code that we do is quite different from what your traditional LLMs can typically handle. It's a lot more complex, a lot more computationally intense. A lot of times it requires PhDs to actually who understand these type of very complex type of algorithms. And a huge limitation for me to actually even reach that stage is that it's very hard for us to find talent. Even then, a lot of them are at much larger American startups as well, doing amazing things for NASA as well. These are just, I would say, practical limitations for us to continue to innovate at that space. Though I think there's a lot of other exciting things that I think we might see, to reach that 100,000x. But we need a lot more talent, a lot more AI type talent.
Cool. Mong, anything to add?
Definitely, there's a lot of lack of talent, and what the skill set is required to commercialize certain products. Edge computing is getting popular. How we can commercialize all this data as edge computing applications. That's we still need a lot of imaginations, and I think not many have grasped the potential yet for using AI with space-based data.
Yeah. I now have a very, very practical question about the future of AI in space. Imagine a 5 to 10 year timeline. What is more likely that in 5, 7, 10 years we will still process the majority of information we get from space on Earth? So we obviously will get much more information than we're getting today. Will we keep mostly transmitting it to Earth and use smart AI here? Or will the future already in 10 years be about much more AI in space, autonomous systems, and making decisions right there? Who would bet on what?
Yeah, again, some of the solutions we are developing now, think about that. We absolutely need to so today we are starting to build optical ground stations worldwide in key data centers and key cities. So Singapore, Barcelona, Australia, Texas, Japan, and a few places. What this allows us to do is mainly government and defense use cases. And these are all post-quantum cryptography secured nodes. What this allows us to do is very secure, let's say, embassy data, foreign affairs data, intelligence data. You want to kind of bring it down because effectively you want the last mile to be people making those calls. Do we fire this missile or not, right? There is a human element to that you always want that done. But we are also on the other hand, there's a lot of deterrence and stuff that can be done from space. For example, one of our first use cases of a data center in orbit is the ability to put an AI which can use non-jammable lasers to an autonomous swarm of drones in high orbit and can coordinate offensive and defensive capabilities. That is best left to AI in orbit to drive.
In one sentence, where will the majority of data be processed, space data? On Earth or in space?
Oh, by far in space. By far, yeah.
Your bet? Floyd?
Space is so much more vast, and there's so much more we don't know, right?
Space.
Just like in AI, so it has to be in space.
Okay, John?
Yeah. I would agree in space, but I still think there's going to be a large amount that's processed on Earth, depending on where the cost leaves the customer.
On Earth because of the cost.
Wow.
If we can fix the energy thing, there, and we can.
All right, we should arm wrestle the answer out.
Yeah.
Well, I think that's a very exciting ending to our panel because the fact that we will process the vast majority of data in space is a huge change compared to what we have today. So stay tuned. There is going to be a lot of cool stuff happening in AI in space, and I hope that all of you will contribute to that. So thank you very much. We're at the end of the session.
Thank you.
Thank you.